This is fundamental problem 2 from chapter 17. If this 80 kilogram cabinet is allowed to roll down the inclined plane, determine the acceleration of the cabinet and the normal reactions on the pair of rollers A and B that have negligible mass. So, once again, for this problem, we can do the sum of the forces in the x direction is equal to the mass times the acceleration in the x direction. The sum of the forces in the y direction is equal to the mass times the acceleration in the y direction, and the sum of the moments of the external forces acting on the object is equal to the moment of inertia times the angular acceleration, but the angular acceleration is 0 in this case. So we have three equations there which we can use. And we need to draw a free body diagram for this situation. So I have the normal reactions on the pair of rollers, and this is B here. So this is NB, and this is NA. And I have the force of gravity acting downwards, and that acts at the mass center. So that's M times G. The mass is 80 kilograms, so this is 80 times 9.81 is 784.8 newtons. Now, instead of having x in the horizontal direction, because the cart is on an incline, I'm going to say this is the x direction and this is the y direction. And the advantage of doing that is now the acceleration is non-zero. Now in the y direction, the acceleration is 0. So the acceleration is only acting in the x direction. So we can say now for this problem, sum of the forces in the y direction is equal to 0, since if you define your coordinate system like this, you have no acceleration in the y direction. But if I define my coordinate system this way, I have to break this force down into components. So this angle here was 15 degrees, which means this angle here is also 15 degrees. So if I break up the force of gravity into components, I had 784.8 newtons, and now the y component here, that's going to be the cosine component. So this is 784.8 times cosine of 784.8 times cosine of 15 degrees, and that gives me 758.1. And then I have a component acting in the x direction, which is 784.8 times sine of 15 degrees, and that is 203.1. Okay, so now I have all my forces, and I broke up the force of gravity into components, and so now I can sum up the forces in the x direction, and I can sum up the forces in the y direction, and then I can do the sum of the moments. So let's start off looking in the x direction. So the sum of the forces in the x direction, let's say this is the positive x direction, so this force is acting in the negative x direction, so that's minus 203.1 newtons. That's the only force that has an x component. So this is equal to the mass, which is 80 kilograms, times the x component of the acceleration. Therefore, the x component of the acceleration is minus 203.1 newtons divided by 80 kilograms. That's equal to minus 2.54 meters per second squared. And that's negative, which means the acceleration is this way, which is what we would expect. All right, so now I can sum up the forces in the y direction. In the y direction, the sum of the forces is equal to 0. And I have NA and NB acting upward, or in the positive y direction, and I have this component of the force of gravity acting in the negative y direction. So that's minus 758.1 newtons And so I can rewrite this and say NA plus NB is equal to 758.1 newtons. Let's call this equation number 1. In order to find those two forces, I'm going to have to use the sum of the moments is equal to 0. And if I'm doing the sum of the moments about point G, then the force of gravity gives me 0. So I just look at the normal forces here. And both of them are acting at a distance of 0.5 meters from this line here. And the normal reaction at A would cause rotation in the positive direction. So for the sum of the moments, I get NA times 0.5, and then I get NB here times 0.5, which is would cause rotation in the negative direction. And so this equation here, if I divide by 0.5, gives me NA minus NB is equal to 0, or NA is equal to NB. That's equation number 2. So using that with equation number 1, if NA plus NB is equal to 758, and if NA is equal to NB, then 2NA is equal to 758.1. So NA is equal to half of 758.1, which is 379.05. Let's just round that to 379 newtons. And since NA is equal to NB, NB is equal to 379 newtons also. And there you go.